Today we're going to be working with the equation section in our flip book. So some vocabulary that you need to be familiar with. When we're working with equations, up to this point what we've been working with is an expression. An equation is a mathematical sentence that uses an equal sign. Okay, so when we don't see that equal sign, we just have expressions. Now we're going to see an equation because we're going to be using that equal sign. So when we have an equation, we are then looking for a solution, which is the value that makes the equation true. And some different ways that we're going to be doing that. One way is by using a replacement set. And a replacement set is a set of numbers that they are asking you to replace the variable with. Once we have that replacement set to replace a variable with a number, then we can find a solution set, which is the set of numbers from the replacement set that make the statement true. And then sometimes you're going to see the word identity. And an identity is an equation that is true for every value. So no matter what number you put in place of the variable, it's always going to make a true statement. So if you go to that equation flap, again, you see the difference. If I just have 5x plus 9, that is an expression. If I have 5x plus 9 equals 19, then I have an equation. So that's the difference between an expression and an equation, having that equal sign in that statement. So as I mentioned with vocabulary, one way that we can work with these is to use a replacement set. So it says to find the solution set of the equation 3x plus 5 equals 26 if the replacement set is, and then they give us the numbers to replace. So we're using this chart. In this first column, those numbers in the replacement set, numbers 4 through 8, have been placed in there. What we're going to do now is just substitute it in. So in the middle, we see the left-hand side of our equation, 3x plus 5. So we're going to substitute the 4 in place of the x. So I have 3 times 4 plus 5. 3 times 4 is how much? 12 plus 5 is 17. We are wanting it to equal 26. So this is false. Then we continue. This time we put in the 5. So we get 15 plus 5, which is 20. So that one is false. We substitute 6 in place of x. 3 times 6 is 18, plus 5 is 23. Still false. 3 times 7 plus 5. 3 times 7 is 21, plus 5 is 26. So that is true. And then 3 times 8 plus 5. 3 times 8 is 24. Plus 5 is 29. And that is false. So then down below that, it says, since the equation is true when x is equal to 7, the solution set is 7. Because again, the solution set is what makes that equation true. So when we're asked to use a replacement set, we need to go through the work for each one of the options. Even if you were able to identify that solution set, okay, need to fill in the whole chart. So I'm going to have you do that on the right-hand side. So as you guys worked through this one, when I substitute 3 into my equation, what do I get for an answer? 13, which makes it false because we're looking for 27. What about when I put in 4? I get a 20, which is still false. What about 5? 5, I get 27, which is true. What about 6? 34. And for 7? 41. So the equation is true when x is equal to 5. So my solution set is 5. Okay? Just one solution that makes that equation true. In this next example, not doing anything different than what we were doing last week when we were working with order of operations. The only thing they've done is written it as an equation just by putting the variable and an equal sign. So we still need to use our order of operations. First thing we do is parentheses. 3 minus 1 is 2. Then we do exponents. 6 squared is 36. Then we can multiply. 4 times 2 is 8. And then 36 plus 8 gives us our answer of 44. Because we are solving an equation, you need to drop down that variable and write your solution as x equals 44. So because we have an equation, I want to see that variable and your equal sign. With that second example, we talked before with our order of operations that division or fraction bar is a grouping symbol. So I need to work the numerator. 15 minus 3 is 12. I work the denominator. 2 plus 4 is 6. That fraction bar tells me I'm dividing. So 12 divided by 6 is 2. So M equals 2. So you can work those next two. When we look at these two problems, what did we come up with for an answer for C? What is T equal to? T is equal to 5. 2 to the third power is 8. 8 minus 3 is 5. What did we come up with for an answer for D with our fraction? What?
1.5.
No, not 1.5. What did you come up with? Okay. K equals 2/3. So in the numerator, 8 minus 6 gives me 2. times 3 is 6. 3 squared is 9. And then we need to reduce or simplify that fraction to get our answer of 2/3. In this third example, instead of doing a replacement chart, they are just giving us a solution to test. So when I look at E, I see two things. I see an equation, n minus 7 equals 18, and then after the semicolon, I see a number. So that's the number they want me to test. So I'm going to take that number and put it in place of the variable. So 25 minus 7 equals 18. What is 25 minus 7? Okay, it is 18. So that is true. So with this next one, I'm going to put 8 in place of the P. Use your grouping symbol or your parentheses. So 2 times 8 gives me 16. Minus 10 is 6. Okay? 6 isn't equal to 4. Okay? So it is false. Okay? 8 is not the solution. So we go ahead with this next one. We put the 10 in place of the variable x. 10 divided by 2 is how much? 5. So it is not equal to 20. The last one, we have 5 plus 28. What is 5 plus 28? It is 33. So that is a true statement. And then our last example for this lesson is looking at identities. So with this, we see lots more going on. We see a variable on both sides of the equal sign. So what we're going to do is just simplify each side of that equal sign. So when I look at this first one, on the left side, I need to distribute to get 6x plus 12. Okay. Cannot add those two together. They're not like terms, so I'm going to leave that. Now I'm going to work on the right side. I need to distribute, so I get, actually here, I don't need to distribute first, because order of operations says I should do parentheses. Here I can combine inside my parentheses. So 2x plus x is 3x times 2 plus 12. Now I can multiply, I don't have to distribute, and I get 6x plus 12. Okay? So those are equal to each other. Okay? 6x plus 12 is equal to 6x plus 12. So that is what we call an identity. No matter what number I would put in place of x. If I did a replacement chart for this, every number that I would put in for x would give me a true statement. Because even though it looks different on the left and right side, when it's simplified, it's exactly the same thing. So I'm always going to get the same answer on both sides of that equation. If I look at this next example, again, looks completely different. If I distribute, I get 4p plus 4 plus 7. And then I can combine my like terms. So I get 4p plus 11, which is exactly what I had on the right-hand side. So again, this is an identity. No matter what number I choose to put in place of the variable, it's always going to be the same on both sides of the equation. So that's what we call an identity. So your assignment for tomorrow is page 17 in your flip book. So you have two charts where you're using a replacement set, and then the other problems are order of operations.
I don't have something.
Turn your page, see if you stapled them in the wrong order.
Oh.